class, we go to this example. You need to find the general solution of the following differential equation. Remember, general solution means that the solution it is in the form of having arbitrary constant. So how to solve this? To find general solution, we need to integrate both sides. Integrate of dy dx equal to integration of 2x. Means that in this case, you can write integration of dy equal to the integration of 2x dx. So when we solve this one, we will have here y equal to 2x squared divided by 2 plus c. Means that we will have here y equal to x squared plus c. When you have here arbitrary constants, means that this one we call it as our general solution. Then, if y0 equal to 3, the question asks you to find the particular solution of the differential equation. Means that when y0 equal to 3, you can substitute y0, which is equal to here. This is the value of x. Means that y0 equal to 0 square. The x here, you need to substitute with 0 plus c. Means that y0 equal to c, but based on the question, y0 equal to 3, so this c equal to 3. So our particular solution in this case, it is in the form of y equal to x squared plus 3, because based on previous calculation, we got here arbitrary constant equal to 3. So this is our general solution, and this one is our particular. Now class, we go to initial value problem and boundary value problem. A differential equation with subsidiary conditions on the unknown function and its derivative are all given at the same value of the independent variable, we call it as initial value problem. Means that if you have differential equation with initial value, so when we plot here at x naught, you know your y naught. So this one we call it, for example, y at x naught. For example, our x naught equal to 0. So y at x equal to 0. Let's say it is equal to 1. When this information is given at initial, we call it as initial value problem. But if the conditions are given at more than one value of the independent variable, the problem is a boundary value problem. It means that if I have, for example, this line, this one is x naught equal to 0, and then I have here, let's say x1, let's say equal to 1. So I know here y naught equal to 0, y1, for example, equal to 2. It means that in this case, you have two values at independent variable x, which is x naught 0, y naught 0, x1 1, y1 2. In this case, we have more than one value of the independent variable, so we call the problem as boundary value problem. If you see here the example, y double prime plus 2y prime equal to this one, and if you see here, you have y0 equal to 1, y prime 0 equal to 1. So you see here at one independent value, we can say that it is initial value problem. But for the second case, we have the same differential equation, but now we have a condition at y0 and also at y1. That is, here you have two independent variable. Means that in this case, we call it as boundary value problem. So class, if you go to this example, which of the following functions are solution of the differential equation? How to solve this? Here we have y double prime plus 4y equal to 0, where we have y0 equal to 0, y prime 0 equal to 1. If you see this problem, this is ordinary differential equation, and here is a initial value problem because we have the condition at only one independent variable. How to solve this? Let's check for this A. A is given by y equal to sine 2x. if this function, a solution for this equation, means that this function, when you differentiate it twice, then you substitute in this y double prime and this y you substitute here, you will got equal to 0. Let's do that. So when we differentiate this one, we got here 2 cos 2x. When I differentiate it twice, I will got here negative 4 sine 2x. When I substitute y double prime and y in this equation, I will have here negative 4 sine 2x plus 4 multiplied by sine 2x, which is equal to, we can cancel out this, we got equal to 0. Means that this one is the solution for this equation. But we need to check here, is it y at x equal to 0 equal to 0? So now we check y0, when here 0 means that this sine 2x, for this x you need to substitute with 0. It is equal to sine 2 times 0. Means that when we solve this one, it is actually sine 0, which is equal to 0. So it's fulfilled for the differential equation. It's fulfilled for the initial value problem y0. And then we need to check for the y prime 0. Y prime 0, it is equal to 2 cos 2. This one is referred to x. Means that 2 here times 0. When we solve this one, cos 0, you'll got equal to 1. Which is 2 times 1, which is equal to 2. When we see here, this one is not fulfill y prime 0 equal to 1. Means that it is not equal to 1. So, not fulfill this condition, we can say that y equal to sine 2x is not a solution for this differential equation. Now class, let's do for B. B, we have y equal to x. When I differentiate this one, I got y prime equal to 1. And then y double prime equal to 0. When substitute in this differential equation, I will have here y double prime plus 4y, it is equal to this y double prime is 0. 0 plus 4 times y is x. So 4x, which is equal to 4x. You can see, based on this one, our y double prime plus 4y equal to 4x is not equal to the left-hand side of this equation. To the right-hand side of this equation means that not equal to the 0. So in this case, we can say that y equal to x is not a solution of this differential equation. Class, we go to C. C, we have y equal to 1 over 2 sine 2x. In this case, when I differentiate this one, I will got here 1 over 2 times 2 cos 2x. So equal to cos 2x. And then I differentiate it twice. I will have here, we need to differentiate this cos 2x. So I will have negative 2 sine 2x. When I substitute y double prime and y in this differential equation, I will have here negative 2 sine 2x plus 4 times 1 over 2 sine 2x. When I solve this one I can cancel out. I got 2, which is clearly it is equal to 0. So it's fulfill this differential equation. So for number 1, it's fulfill this differential equation. Now we check for y0, is it equal to 0? Y is given by this equation. So when x equal to 0, this x we need to substitute with 0, which is equal to 1 over 2 sine 2 times 0. So here sine 0 it is equal to 0 means that this one equal to 0. It's fulfill this initial condition. Now let's check for y prime 0. Y prime is given by this equation. So now when we substitute x here equal to 0, here this one equal to 0, y prime 0 equal to cos 2 times 0. That is cos 0, which is equal to 1. So you can see this y prime 0 equal to 1. that is, it's fulfill this condition, means that now it's fulfill these three things. So we can say that y equal to 1 over 2 sine 2x is a solution for differential equation. So class, it comes to the end of week 1 video. Thank you for your attention. See you in week 2 video.